Hey Nick, I have your test here. I shared over conferences that I wanted to go through the questions that you missed to help you review since we don't have a lot of time once we come back from break. Okay, so taking a look at your test, remember that this very first page was no calculator and no notes. This is computation based, so we were trying to make sure that you knew some of these things on your own. So for the first three questions, number one, A, B, and C, it says to use the numbers from the box to complete each equation. You got letter A right. Square root of 36 is 6 because 6 times 6 is 36. But for letter B, the square root of 8 is not 4. 4 times 4 is not 8. 4 times 4 is 16, so we should have had 16 there. And on letter C, I'm not sure what happened here. You wrote 14, but there's no 14 in that number line, so or in that box of answers to choose from. It should have been 11. 11 times 11 is 121. Down on number 2, we did talk about this, you and I, when we were working on a homework correction recently, but when it says what two integers does the square root of 30 fall between, remember these two numbers have to be consecutive, so 3 and 4, or 4 and 5, 7 and 8. So 3 and 11, that's not an option. Also, we're not picking numbers from this box anymore. I'm not sure if you were thinking, 11's up here in this box, but the box of numbers to choose from was just for those first three questions. So when we start taking a look at the square root of 33, we're trying to figure out what two perfect squares does it fall between. So if I start at 33 and I work down, 32, 31, 30, 29, 28, 27, 26, 25. So the square root of 25 is 5. That's a perfect square. That's the first perfect square less than the square root of 33. If we go the other direction, 34, 35, 36. 36 is the other perfect square that's above 33, so that's 6. So that means that the square root of 33 falls somewhere in between perfect squares 25 and 36. So square root of 25 and the square root of 36. So our answers here are 5 and 6. Again, those two numbers have to be consecutive. For letter 3, we're just trying to determine the value of each cube root. So what number times itself 3 times gets us 27? So I'm going to kind of work through both of these together. If I start with 1 cubed, again, we didn't have a calculator and we didn't have notes. We're not going to pick numbers that are huge because the computation on your end would be too difficult to try to answer these. So we were trying to pick smaller ones that maybe we would know or we could get to pretty quickly. 1 cubed is 1 times 1 times 1, that's 1. 2 cubed is 2 times 2 times 2, that's 8, right? 2 times 2 is 4, 4 times 2 is 8. 3 cubed, 3 times 3 times 3, 3 times 3 is 9, 9 times 3 is 27. There we go, there's the first one. The answer is 3. Remember, you're saying what number times itself 3 times is 27. We get to 4 cubed. 4 times 4 is 16. We probably don't know what 16 times 4 is off the top of our head, so we're going to have to do that math off to the side. 6 times 4 is 24. 4 times 1 is 4, plus 2 is 6. So we do get 64. But remember here it was asking for a negative 64, so we just put a negative on our answer. Negative 4 times negative 4 is positive 16, but positive 16 times another negative 4 takes us back to negative 64. Okay, let's move on to the multiple choice. Number 1 says the product of W and 8 is 32. Remember here that product means multiplication. So we should have written an equation that looks something like this. 8W equals 32. The product of W and 8 means we're multiplying those two things together. When we multiply a letter and a number, and we put the number in front. So 8W is, that's the equal sign, and then 32. We should have been dividing both sides by 8 to get that D equals 4. Number 2 says, which of the following equations have a solution of x equals 15, circle all that apply. Now you have some options here. It looks like you went ahead and solved them all. So we got 13 for the first one. And then here we should have added 100. Subtracting 9 is 5. 5 times 3 is 15. I think I meant to put the slash through C, and instead I put the slash through the correct answer. So there were two right answers here. B is correct and C is correct. So you're certainly welcome to do what you did and solve all three of the equations to see if you get 15 for an answer. The first one you solved correctly, so that one is not correct. I don't see where you solved this one, but I'm guessing that if you solved C and you didn't get 15, that you thought maybe B had to be the right answer. But on letter C, I want you to look at your work here. So you added 40 over to this side. Remember, we're trying to take things away from the variable, so our first step should have been adding 100 to both sides, and that would have given us 4x equals, and then you didn't add correctly. Remember, that's a negative 40. Over here it was a negative 100, but negative 40 plus 100 is 60. So we should have gotten 4x equals 60. And then when we divide both sides by 4, we get x equals 15. So we should have circled B and C. On letter B, if you subtract 9 from both sides, 14 minus 9 is 5. And then we would have multiplied by 3. 5 times 3 is 15. So that one should have been B and C. I also am not sure because I scanned this, after you had it back, if maybe you marked answer B. Typically on this one, it's worth 2 points because there were 2 right answers. So you just lost 1 point for not having one of the right answers. 3 asks for the solution of the equation. So here we have variables on both sides, and it looks like you took 5m and 2m and added them together and got 7m, but I need you to remember that those are on opposite sides of the equation. And I'm actually going to move down here where I have a little bit more room so that I can show you how to correctly solve this. So we do need to get the variable on the same side, but that's done by, remember when you're moving terms all the way to the other side, you have to do the opposite. So we would have subtracted 2m from this side, and that would have been 3m plus 7 equals 28. And now I have to take everything away from the left-hand side that's with the variable. I'm going to start by subtracting 7, so 3m equals 21. And now we're going to divide both sides by 3, and we get m equals 7. So that one should have been letter C. Okay, moving over to the true false. So when we draw a square and we talk about the area, and you and I actually also worked through a question like this on a redo of your homework the other day. So since you've taken the test, you and I have talked about this once, so let's talk about it again. So when you're calculating area, remember that the sides of a square are all the same. So when I find the area, I just do one side times the other side, or multiply the side length times itself. And that gives me the area. So really, when you know the area, you're just square rooting this number. Well, the square root of 25 is 5, right? 5 times 5 is 25. So I know the side lengths of the square. Each side of the square is 5 inches. That's true. One side of the square is 12.5. Now that has to be false because we just proved that it's 5. The perimeter, right? The distance all the way around, 5 plus 5 plus 5 plus 5, or 5 times 4 is 20. So when you know the area of the square, you take the square root of that number and it will give you the side length. Question number 8 asks to solve this equation. So you started correctly by subtracting 5 from both sides, and we got x squared equals 50. So I want to focus on this answer here. X squared equals 50. And then you divided both sides by 2. Remember, x squared is not the same thing as 2x. If it had been 2x equals 50, then we would have divided both sides by 2, but it's not 2x, it's x squared. How do we get rid of an x squared? we square root both sides. Remember, square rooting something that's squared, they cancel each other out. So I get x equals what? When we square root, first of all, we're going to get plus or minus always. So what is the square root of 50? Well, now you're back to using a calculator or your notes. 50 is not a perfect square. When it says to simplify, it means we don't want decimal answers. We want to do a factor tree. And I know I'm kind of running out of room here, but this one's pretty small. So 2 and 25, and then 5 times 5. Your pair comes out in front, and anything that's left over goes back underneath. So the correct answer was plus or minus 5 square root 2. Okay, so as I look at equations, I try to, give students partial credit where I can. On number 2, you did add 5 to both sides. That is the correct first step. But remember that this p over 4, that's division. And I undo division by multiplying both sides by 4, right? The multiplying by 4 and dividing by 4 cancel each other out. And it's almost like you did that. I see this tiny little times 4. I think that's what that says. But then when you multiply by 4 on this side, that 4 goes away. So the answer was just p equals 28. And then it looks like you put the 4 up with the p. Instead of canceling them out, you went ahead and multiplied p by 4, and then you divided by 4 again. So I just want to make sure you see where the error was there. That when you have p, a variable divided by a number, we got to multiply to get rid of that. Number 3, you really just missed a half a point for missing the negative, right? You combined these two terms together first, which is the correct right step, but 6 minus 10 is negative 4, so we should have been dividing by negative 4, which would have given us m equals negative 9. The mistake you made on 4 was similar to the mistake that you made up here on number 3. So again, we have variables on both sides, right? I have 8d on the left and 5d on the right. I don't combine them and say 13d. I'm trying to move one of the terms over to the other side. So I'm just going to rewrite the problem here so I can work through it. So we should have subtracted 5d, just how you subtract 2.8 to get rid of positive 2.8, and just how you add 5 to get rid of negative 5. We are subtracting 5d to get rid of a positive 5d. We want to get things on the same side. So those cancel out. We get 3d plus 6 equals 39. And I'm fairly confident that had you gotten here, you would have been okay because you're pretty good at solving the two-step equation. So now what do? Now we're trying to isolate the variables. So we undo addition first. 3d equals 33. And then we're going to divide both sides by 3. And we get d equals 11. So unfortunately on that one, just kind of starting off by not doing the correct first step just doesn't set you up for doing well after that. And I did notice too that you divided 45 by 13, right? So had this been correct, we would have divided by 13, but 45 divided by 13 isn't 3, it's a decimal. So you maybe would have gotten some more points had you had the correct, answer here for this part, even though that wasn't correct. Okay, infinitely many on number 6. You kind of got lucky here on number 5 because again, this is another one where they're on opposite sides, but you added them together. We really should have been subtracting 3x because I want to show you what happens when we do that. If I subtract 3x from both sides, right, I'm moving the variable term to the other side by doing the opposite. Then I end up with this statement, 1 equals 4. That's not true, and we do get none. It was kind of hard to recognize here if maybe that was still making sense. Based on your work doesn't make a ton of sense, but some students can still kind of see this 1 and 4 here on their own, so I did give you the benefit of the doubt here. This is not one that I will ask you to redo on the test, but I did just kind of want to point that out. These equations, this number 5, this one here, number 4, and then that multiple choice number 3, they're all the same type of question where we've got the variable on both sides. So we should be doing the opposite and not, you're trying to add them together as if they're on the same side. Okay, Kyle stated there's no solution. And again, this is that same kind of case, right? Here's a 2x and a 2x. They're on opposite sides, but you said 4x. We can't do that. We should be subtracting 2x from both sides. Subtracting 2x from both sides. Those cancel out completely, and I end up with this weird statement. I don't have any variable left over. This is not true. There is no solution. So again, I wasn't sure on that one if you were thinking, well, I see the 12 and the 6, but that 4x equals 18. This is not what we should have been doing there. That's not how you solve an equation. Okay, on number 8, you went about this, there's pretty much 2 methods to solving this. You went about this a correct way, but then gave the wrong answer, right? So if it's going, so let's just read it. A courier service charges a flat rate of $12.50 per trip plus 60 cents per mile. They charged films and more $23.30 to deliver a package. How many miles did the courier service have to travel? So I think the first thing that you did, although I don't see it on your paper anywhere, is you took $23.30 and you subtracted $12.50. Okay, taking the total cost to deliver minus that flat rate that I'm going to have to pay no matter what is $10.80. Okay, and I can see that here. $12.50, the flat rate, plus $10.80 is $23.30. So basically, what are we saying here? I have this flat fee of $12.50, and I have $10.80 worth of travel. That's 60 cents per mile up to $10.80. And then I'm not sure, this must have come from the calculator, or it was a really lucky guess, but 18 times 60 cents is 1080. The answer here is 18 miles. How many times are you charged 60 cents? You're charged 60 cents 18 different times to get you up to 1080, which is the part of your overall fee that's the mileage cost. Now, what I was hoping to see from students is to write an equation, and we didn't. Clearly, there are definitely 2 ways to solve this, but if it's $12.50 flat per trip, I have to pay that no matter what, plus 60 cents per mile. Remember, when we hear the word per, that means multiplication, and I don't know how many miles. That's what I'm trying to figure out, so there's my variable, for a total of $23.30. That's what the equation would have looked like. Subtracting $12.50 from both sides, you're going to see a lot of the numbers, a lot of the work you had here. 60 and that's 1080. And now what do? We divide both sides by 60. How many times, excuse me, by 0.60. How many times does 60 cents go into 1080? And then we would have gotten 18 miles. So you've got the thought process is there. I can see you were doing the right steps to figure that out, but then this is actually money, not miles. These were your miles here. And I would guess that to get 18, you probably grabbed a calculator and did 10.8 divided by 0.6, which is what you needed to do, but then again gave that wrong answer. And we did well on 9 and 10. Oh, darn. And on 11 and 12, what did we forget? Just the plus or minus. Anytime you solve an equation that involves an x squared, remember we get 2 answers. The positive solution and the negative solution, because a negative times a negative is a positive. So again, just remembering when you retake that anytime you solve the x squared equations, we need to include that plus or minus. So just lost a little bit there, just a half a point. So when you retake this test, a little bit different from last year. We are just asking students to be accountable for the information that they missed. So when I hand you your test, a new test back, you will have just certain questions highlighted that will match pretty much what you missed on this version of the test. So really that's where we want your focus to be. The thought process behind that is that students like let's say a question like number 5, you knew how to answer that, so I don't want you to have to, retain all that information. What am I really focusing on is you getting correct the things you missed the first time. So after you watch this, if you have any questions, feel free to reach out. We're going to go ahead though and try to get this started pretty much right away when we get back from break. Maybe not Monday, but Tuesday for sure. And I will see you Monday.